Hello and welcome everyone. I hope you are all doing good and can hear me loud and clear. Today I have a very special topic. We will talk about the validation of the scanner accuracy, and as always I'm having Tobias connected also via Facebook, and if you have any questions please write them down in the comments and we will respond as soon as possible. Yeah, I hope you can hear me good. I will talk about a special model we have here from our R&D department, and we are performing some accuracy tests with them in order to provide you accurate device and a good working software. But before I'm going to tell you something about the validation of the scanner accuracy in general, we have to talk about the definition of accuracy. So we can divide this into two parts. On the one hand side, we have the precision, and on the other hand side, we have the trueness. And I'm going to explain this to you. So the word precision means that is a measure of similarity between independent measurement results under fixed conditions. So, and to explain it a little easier, I got a picture for you right there. And you see the purple points, and each purple point is a measurement. So high precision is when many measured values are very close together. And you see it right there. The purple points are very close together. So the precision is in general very high. But you might have noticed, it's not in the middle and we are not at the 10 right there, so the precision is high, but we are not close to the real values. So therefore I'm explaining you what the definition of the word trueness. So trueness is a measure of the correspondence between the mean value obtained from a large data set and the accepted reference value. And this is what I'm going to talk about a bit later when we are measuring this model and afterwards loading it into the CAD software, because we have the reference values available and we are going to compare them with the values we are going to collect with the vinyl scanner. But I will also explain this a little bit more in detail. So again, each purple point is a measurement, and you see that we are close to the 10. So we have a good trueness, and the values are in correspondence with the true value. So the precision is not that good. We have some purple points right at the 10, but we also have some at 8 and 7. So yeah. In general, you have to, what is important, you have to combine these two. So high accuracy means that the precision and the trueness is good, because when you are having, for example, the first scan after the calibration is very good and close to 10, but after the second or the 50th measurement you will have bad results, then it's useless. So we are also checking the accuracy after a lot of scans. That's very important. So that is the topic for the definition. I'm going now to open the dental scan software right there. I'm going to use this model adapter and fixate the model on the adapter and make it very tight. It's very important that this model is not moving around, so I'm using this special adapter. I'm also going to close the lid, and we are starting with a new project. I'm selecting the 1.8 as a stump, and if you press Control, you can also select them like this. For the scanning mode, I'm going to use one stone model, and presentation will be the second die. Okay, I'm going to press Start, select the upper jaw. Okay, now it is important to bring the area perfectly into the middle of the measurement field. and this is looking quite good. Also important is to activate the high resolution scan, and yeah, we are going to start. Yeah, you have to select the stumps, so to say, in the second die mode. This is not necessary when you have the multi-die or a complete draw. Only in the second die scan you have to select the stumps. Okay, I'm going also to click on the next button. Yeah, what you will see, we have a very good accuracy, very good global accuracy, and we will check this when we will check the scan file in the CAD software afterwards. And yeah, you will see that even for implants, we are not limited, and yeah, you can completely trust on the values we are capturing with the device. Okay, just a little hint for you. If you double press on the project, let me see where it's opening, you can directly go into the working folder right there. Okay. Scanning is still in process because we selected a good scan strategy. Okay. So the scan is finished. Now I have the automated cutting plane. I'm going to lower it a little bit. Yeah, if we have some areas which we did not capture enough, we can use the rescan. And yeah, but that's not necessary. I'm going to start matching and close the software. Take the model outside of the device. Remove it. Okay, now we have to wait until the matching is finished. So, and what we are going now to do now is we are taking the PLY file, load it into a different CAD software, and then we are calculating the balls, and afterwards we are checking the distances from the balls to each other, and yeah, compare that with the mean values we have received because, as you know, this model is measured on a huge tactile coordinate system, and we are comparing it with these values to check the trueness and how accurate the device really is. So just have to wait. The matching is now finished. Let me just select the object. Meanwhile, I'm going to open the GOM inspect for that. So where is the upper jaw? Just a second. Oh, sorry. To close it. Okay, I'm now going to drag and drop it directly into the CAD software. Now it asked me to import the PLY. As a unit, we are choosing the millimeters, and target element type will be the mesh, but you can also select point cloth or color mesh. I'm going to press OK. Good, looking good. What we now have to do is we have to create some fitting balls in order to then create some distance between, and I'm going to show you how to do this. So we are going for construct, and then we have to select fitting square right there, and we leave everything as it is. Use points 1 sigma is totally okay. I'm going to hit the control button again, select the first ball and create, and I'm also doing this for the second ball. Create, third one, create, and the last one, create and close. Now we have to create also some distances between them, and therefore we are using a 2-point distance right there. I'm going to select square 1 and 2, create. Then I have also to do it for the distance between 2 and 3, and so on and so on. I will just perform that right now. Great. Then we have 4 and 1. Great. 2 and 4. And last but not least, 1 and 3. Create and close. So now we have the distances between the balls with the scan we did by ourselves, and we want now to compare it with the real value we received from the lab in order to check how true the values are that we have scanned a couple of minutes ago. So therefore I'm going to use the inspection mode. We have to check the distances, and we want to check it against a fixed value. Okay, but first I have to select a distance. Okay, just again, check dimensions, distances. Okay, now I have to insert the distance we have received. Just a second. 7783. 83. Okay, I'm going to press OK. And what you now see is the real deviation we have between these two balls. And this means we have to make a calculation, because this is in millimeters, but we have to, we want to show it in microns. So this would be 4.65 microns deviation between these two balls. And you might have noticed this is a very, very good and accurate result. And this is very important for implants, that you have a good accuracy at a specific point on the model, but also on a large field between these balls, for example. So, but I'm also going to check the dimensions and the distances for this area right there. I have to check it again with the results we have received. 9060. Okay, and you see on this distance we have a deviation from 1.3 microns, which is also very, very good result. So let me continue. Check deviations, distances. Oh, come on. Okay, here we have again the deviation from 2.3 microns from ball 3 to ball 4, which is very, very good, and I'm very happy with this scan. We are continuing with the other ones. Sorry, this takes some time, but we want to have it in very detail. Oh, I've selected the wrong one, just a second. Okay, also very good result, 3 microns between ball 1 and ball 4, always in comparison to the real value we have. You see it here again. We have the actual values right there, and we have the nominal values which we just typed in, and this is these are the values we received. So let me continue, check dimensions again. I have to enter that manually again. Okay, 5 microns, and last but not least, we are going to check this as well. Zero, and we are done. A deviation from 6 microns. So you see the deviations are very, very low, and you have very good trueness right there. Of course, we are performing these tests not once for the device. You have to do it directly after the calibration and after 100 scans or 1,000 scans to check also the precision. And yeah, that's basically how we are working at the R&D department, and just a little insight on how to check the accuracy from a scan data. Don't always have a look at the beautiful 3D files you see in the viewer. Always make sure that you have the possibility to also check it. And yeah, that is everything for today. Thank you very much for listening. Tobias will give the next presentation on Tuesday because Monday is a national holiday in Germany. Yeah, he will show you the combine mesh feature and the correction scan. And yeah, thank you very much for listening, and yeah, enjoy the holidays and the weekend and stay safe, and see you next week. Goodbye.